All right, here is the video guide for lesson 3.1.4 on, again, using equivalent ratios, but we're going to investigate it further with different situations and making sure we're focusing on the correct notation when we're writing similarity statements or we're writing these equivalent ratios. First problem is going to have us investigating these ratios. And the first thing we need to point out is the one that they're choosing to use is BC over EF, so B to C and E to F, equals AB, the bottom one, over DE. And that is one way that we can set up a proportional equation if we know the two shapes, in this case triangles, are equal to one another. Okay? And notice how they're using the letters. They're saying B to C, E to F. And so they're even making sure that it's going from the right vertice to the next vertice in terms of writing it. And that's going to be important. And so we need to write three different ones from the ones that they used. And there's a ton of different options. We just need to do three more. Part B here, it says we have angle M equal to angle D. We have angle C equal to angle F. And then are we able to conclude that angle B and angle E are the same? We know these two are the same. Are we able to say the third one's going to be the same? And we need to justify our conclusion if we think yes or if we think no. Okay, and think triangle sum theorem. What would the triangle sum theorem tell us? Here we have this math notes. It's going to tell us to read the math notes in the next box, and it's an important one to read. So make sure you spend the time and understand what they're saying here. And so it's talking about two figures being similar. Okay, and what it means to be similar is that you can perform these similarity transformations, meaning rigid transformations and dilations. If you can perform those transformations and have them land on top of each other, we know the shapes are going to be similar. And when we know two shapes are similar, like these two triangles are, we can say triangle ABC is similar to, that little tilde, that little line means similar to triangle DEF. Okay? The order of the letters is the same, or the order of the letters in the name of each triangle determines the sides and angles that correspond. Okay, so angle A and D are corresponding. So D and A, they correspond, and you can maybe see that. AB, as you see here, AB corresponds to DE, and that's why it's written as such. And so the order of those letters matters, and that's going to be useful for us when we're writing notation later in this lesson. On to the next one. We need to describe the series of transformations that would get this triangle DOG on top of this triangle CAT. Okay? And so you got to use reflections, rotations, translations, or dilations to get it so that they're exactly on top of each other, and we want to describe what those transformations were in the series you used them in. Okay? The next part here, and it's a little small to see, you might have to zoom in, okay? We want to write the correct way to write the similarity statement. And again, the order of the letters matters. So if you say D-O-G, well, then you're probably going to have to say C-T-A because C corresponds with D, T corresponds with O, and A corresponds to G. And so then you would circle that one. Okay? If there's other ones that work, you circle that as well, and then you explain why you chose the ones you chose. Here we have practice, again, figuring out our missing values using similarity. Okay, so you want to set up equivalent ratios and solve for x by cross multiplying, or you want to find the zoom factor by dividing new shape divided by old, and then use the zoom factor to find the missing side or the variable. Okay, and we have this problem that's like that, this problem that's like that, and this problem that's like that, and I think we have one more. This one here, and this one here usually trips people up, okay? Because you say, I don't really know whether to use the 7 or the 6 to correspond with the M. Well, look at the similarity statement, okay? AB goes with XY. So AB here is 7. It goes with XY here, which is M, which means the 7 and the M, those are the corresponding sides, okay? Just like we see here, XZ, so X is the first, Z is the last. That must correspond with A and C, because those are the first and last in this one. And so we can set up our equivalent ratio knowing which sides we have now and solve for M. Here is kind of a challenging problem, so I'm going to work through it a little differently and kind of give some things away. All right, so it's asking, why do we know the two triangles are similar? Well, it says in the instructions up here that Rochita drew ABC at the right and then dilated it to create A, B prime, C prime. And so I know they're similar because I know that the first one just got dilated. And if you're just dilating a shape, they remain similar. I can say shapes remain similar when a dilation is performed. Something along those lines. I think it's performed. Okay. What is the relationship of the side length AB prime and AB? And so what we can say there too is that we know that those two sides are corresponding. Those two sides correspond. What we can also say is that AB prime and AB, they're going to be proportional, because like I said in the first part, all right, they are corresponding sides of similar figures, and corresponding sides of similar figures are proportional. And so we can state that here in the bottom box, either that they're proportional or that they're corresponding or both. Okay. She decides to redraw these two shapes as such. So x plus 9 is the full side, 10 is the full side, and that's why we see x plus 9 and 10. And then on the small triangle, we have 4 and x. So she just redrew the two triangles. Okay. We want to write a proportion solving this for x. Okay. And what that might look like is our corresponding sides AB and AB prime. So that could be 4 divided by 10, set equal to our other corresponding sides, which would be x divided by x plus 9. Now this looks kind of weird, but you can do 10 times x, we know that. And then we could do 4, let's scroll down a little bit, we could do 4 times x plus 9. We can do that. It's a little bit of algebra, but we can distribute that 4 into each term, and we can actually do that multiplication. Okay? Then when we have it, we should have this set equal to 10x. We should be able to solve it for x, and then we should be able to plug it back in to find AC and AC prime. Okay? Keep going with this problem. We want to look at the ratio of BC and B prime C prime. Okay? So we're going to figure out the ratio from figuring out what x is here. All right, and then once we have our ratio set up, we can say that, well, BC and B prime C prime are going to have that same ratio because this is a similar shape. And similar shapes have those ratios. The last thing here is they're asking for a relationship between B prime C prime and side BC. Okay, so this side here, B prime C prime, and this side down here, BC. What I see here is that this is a triangle. This AB prime C prime is a triangle. ABC is a triangle, and we know they're similar. And we know the angles in similar triangles are the same. Because similar changes side length, similar doesn't change angles. Which means this angle right here, angle B prime, is the same as angle B. And if we look at this, what this tells me is that these are corresponding angles being equal. And the only time corresponding angles are equal is when you have a pair of parallel lines cut by a transversal. So what that tells me is my parallel lines here are B prime C prime and B and C. And so there's a relationship right there for us. Those two lines would be parallel because we found corresponding angles that are equal. Lastly, a learning log. Please try to fill this out to the best of your ability and try to reflect on the lessons that we've gone through so far. How can you compare two similar objects? What kind of quantities or quantities with equivalent ratios? Okay, how do you set up those equivalent ratios? What do you normally do? Go into detail here. Really try to reflect on what you've been learning in the last 4 lessons at this point. With all of that, make sure that you send emails on any problem that you're stuck on. I'm happy to explain a problem further or even work a problem for you. All you need to do is ask.